This video is meant to go over a review for a calculus test on rates of change for the MCV4U course in the province of Ontario, Canada. And I'm using the McGraw-Hill Ryerson textbook for this. So let's start with some multiple choice here. And all 6 of these questions pertain to this graph on the right here. So this is about piecewise functions and limits. So the first one asks, what's the limit of this function as x approaches 2? See the little negative there? It means from the left side. So this is where x is 2 here. So from the left side means we're coming down here. And as you get close to that point, the y value or function value approaches 8. So that's why D would be the correct answer for question number 1. The second one, there's a little plus here, which means you're approaching from the right side instead. So from the right side, again, this is where x is 2. So we'd be coming along here from the right-hand side of where x is 2. And so we're getting close to a function value of 5, which is answer B here. So B would be the correct answer for number 2. And so to evaluate the limit of this function as x approaches 2, because of the fact that these two limits are different, one's 8 and one's 5. If the right-hand limit and the left-hand limit, that's what these are, this is the right-hand limit, that's the left-hand limit, are different, then the limit is said not to exist. So that's why C is the correct answer for question number 3. In questions 4, 5, and 6, we're now trying to find a limit around 5. And so we'll start with the left-hand limit first, a little negative here. So where x is 5 is right here. So for the left-hand limit, we're approaching from this side here. So we're approaching that point right there from the left. And so y, or the function value, is 3 there. So that's why 3 is the correct answer for question number 4. For the right-hand limit, we're approaching 5 from the positive side, or the right side. So we're coming along here, getting close to where x is 5. And again, the function value is the same. It's 3 again. So B is the correct answer for number 5. And then question number 6 asks, so what's the limit of this function as x approaches 5? And because of the fact that these were both 3, then the answer is 3. The limit of this function as x approaches 5 would be 3. So B is the correct answer for question number 6. Moving along to part 2 here, so some graphical questions first here. So we have a parabola here, and the review, and there will be a link in the description here if you want to access this and the solutions to it. You'll find just the parabola. So these triangles and lines that I've drawn are for the solutions for A and B here. So in A, you're asked to find the average rate of change between where x is 1 and 4. So where x is 1 would be right here, where x is 4 would be right here. So the average rate of change is the slope of the secant between where x is 1 and where x is 4. So it's really just the slope of the secant line. And so, and I'm going to switch to my pen here, along the bottom here, if you count the run here is 3, and the rise is 3. So the rate, or the slope, will just be, it's just the slope here. Rate is rise over run, slope is rise over run, so it's 3 divided by 3, which is 1. So the average rate of change from where x is 1 to x is 4 would be 1. For question B, you're asked to find the instantaneous rate where x is 0. So where x is 0 would be right here. So we're talking about this point right here, which is the point 0.05. So what I did was I drew a tangent line there. It's this purple line that you see is intended to be a tangent, so it's just touching where x is 5 here. And so to calculate its slope, again, rate is rise over run, slope is rise over run. So we measure, or look on the graph and find what the rise and the run are. So across the bottom, the run here is 3. And if you count down here, this is going down 11. This point here is actually at 12, and this is at 1, so from 12 down to 1 it's gone down 11. So the rise is negative 11, the run is 3, so the rate would be a negative 11 thirds. I'll just write the negative out front. That's a more accepted way to write this fraction than leaving the negative on the top. So the rate's negative 11 thirds. That's the instantaneous rate at that point. For question number 2, we're asked what's the average rate of change between where x is negative 1 and positive 2 for this function. And so this is really, again, still just a slope calculation. This is like the y2 minus y1 over x2 minus x1. Y's are function values, so we're going to find f at 2 and f at negative 1, and that'll be difference between the function values there, which is really just the rise, and the run across the bottom is the difference between 2 and negative 1. So f of 2, we're going to substitute 2 in the function, so we would go negative 2 times 2 squared. That's what this is. And then minus 5, we're going to put 2 in here for the f of 2, which should be minus 5 times 2, plus the 3. So this much right here is the f of 2, right to there. And then, so that minus is that minus right there. And f of negative 1 will be found by putting negative 1 in here and here in the function. So that's what's in the brackets here. So negative 1 here, which is there and there. So this much here is the f of negative 1. Now, the reason I've crossed these 3's out is because when I take the brackets off, it'll be 3 subtract that 3, so they will subtract to 0. And so while we start evaluating here, 2 squared is 4 times negative 2 is negative 8. Negative 5 times 2 is negative 10. My 3 is gone. So this will be a negative 1 squared is 1 times negative 2 is negative 2. So that's negative 2. And then when we take the brackets off, that's going to change that. Well, actually, I guess I left that here. I didn't take the brackets off yet. There's negative 2. And negative 5 times negative 1 is positive 5. So in the next line, we take the brackets off. Subtracting negative 2 is the same as adding 2. Subtracting 5 is minus 5 here. And so negative 8 minus 10 plus 2 minus 5 is negative 21 over 3. So the rate is negative 21 thirds. On to question number 3. In question number 3, we're given this rational function f of x is 4 over x. We're asked to calculate this rate of change value, and we're asked to find what the rate of change is, where if a is 3, so the x value at this point is 3, and h, the distance between these two is 0.01, 1/100th. So 2 ways you could do this. We could just substitute the 3 in place of a here and the h in here, the 0.01 here, and evaluate. Or I'm going to do this algebraically, which is more like the first principles definition of the derivative, because that's what I'm kind of leading into as I go through this review and the assignment and test that goes with it. So that's why I'm going to do this algebraically and substitute those in at the end after I've simplified this. So if I want to find f of a plus h, I put my a plus h in place of x here. So it's 4 over a plus h, which is what this is right here. Minus f of a, I put a here, so that's 4 over a over h. That h is that h in the denominator. So in order to subtract these, I need a common denominator. So the two a plus h and a denominators have no factors in common. They might both have an a, but that's not a common factor. So in order to get a common factor, it's the product of this a and this a plus h. So basically this one needs to get multiplied by a, which is what I've done here, and this one needs to get multiplied by the a plus h, which is what I've done here. So the two denominators now are a and a plus h. I've written them in different orders here maybe, but they are the same denominator. So in the next line, and then it's over h here, that's that h right there and there. So 4 times a is 4a, minus 4 times a is minus 4a, and negative 4 times the h is minus 4h. That's what's on the top here. I've written it over the common denominator, which is a plus h. Again, I guess if you wanted to write that a over here like I did there, you could, but it's the same denominator. So these negative 4a minus 4a, they add to 0. So we're just left with negative 4h on top over our common denominator over the h. And let's move this up a little bit. That's good enough. So now what I want to do is I want to simplify this because I have this rational expression divided by this h. And that h, that's the same as h over 1. So I'm going to take the rational expression on top, which is what's here, and I'll get into why this is crossed out in a moment, and multiply it by the reciprocal of that, which would be 1 over h. So now these two h's will divide out, because h divided by h is 1. So now in the numerator, I have just negative 4 times 1, which is negative 4, over a plus h. And now that I've simplified this, I'm going to substitute my 3 in for a and my 0.01 in for h. So 3 in here, and 0.01 in place of h. So 3 plus 0.01 is 3.01. And then I can multiply it together to get 9.03. And we'll bring our calculator over here. And so negative 4 divided by 9.03 is about negative 0.443. Oh, I missed my negative. Let's fix that. So there should be a negative here. And so that's question 3. So let's move on to 4 here. So in question 4, we're told if the population n of t is for a group of penguins, is projected to follow this function. N of t is the 4t squared minus 3t plus 600. T is the time in years. N of t represents the population at that time. They're asked to find the average rate of growth from the 3rd to the 4th year. So this is actually a lot like this question right here. Okay, saying we're finding an average rate of change between, well, the 3rd and 4th year in this case. So we to find the difference between the population, which is really the rise, we find the population at 4 years, the population at 3 years, and subtract them. And then over the amount of time, from the 4th year to the 3rd year, 4 minus 3 would be the amount of time, which of course is 1 year. So n of 4, we'll put 4 in place of time here. So 4 times 4 squared minus 3 times 4 plus the 600. And then n of 3, we'll put 3 in here. So 4 times 3 squared, 3 in here, minus 3 times 3 plus the 600. And just like the previous example, 600 minus that 600 would subtract to 0. So that's why I crossed those out. So 4 squared is 16 times 4 is 64. Minus 3 times 4 is negative 12. 3 squared is 9 times 4 is 36. So when we take the brackets off, that's going to be a minus 36. And negative 3 times 3, that's negative 9 there. But when we take the brackets off, that will change it to a plus 9. Now it's over 1. That's why I didn't bother put the over 1 anymore. And so 64 minus 12 minus 36 plus 9. Let's just do this to verify that this is correct. So 64 minus 12 minus 36 plus 9 works out to 25, and it's a rate. Make sure you put those rate in an application. Make sure you put the units. The population is the number of penguins, and time is in years, so it would be 25 penguins per year. The population from the 3rd to the 4th year is growing at a rate of 25 penguins per year. Question number 5. So same formula. What we're asked to do now is find the instantaneous rate of growth in the 3rd year. So we're getting into actually evaluating the value of the derivative. The instantaneous rate of growth is the derivative value at a specific point. And so n prime was what we're finding here, will be the limit as h tends towards 0 of n of t plus h minus n of t. I'm using t here because that's the variable in the formula over h. So to find n of t plus h, we put t plus h in here. So 4 times t plus h squared is what's here. And we put t plus h here, be minus 3 times the t plus h. And then plus the 600. And again, that's going to subtract to 0 with what's in here. And n of t is just this. We're putting t in place of t. So that is exactly what's here. So those 600s are gone. 600 minus 600 is 0. So I want to square the t plus h. Now there's a shortcut for this, but I'm going to just do this sort of the long way if you don't know the shortcut. T plus h squared means 2 of these multiplied together. So t times t is t squared. T, okay, so I've done that. So this is next, so plus a th. And then these multiply to a second th. And then h times h is h squared. And so it's t squared, 1th and 1th is 2th plus h squared. So that is what's in here. Now, the shortcut, if you want to know how that works, you square the t, so that's the t squared. You square the h, that's the h squared. And since you're squaring this binomial and not multiplying two different ones, t times h doubled is the middle term, because there's always going to be two identical terms when you're squaring here. So now I'm taking the brackets off, so this can be minus, oh, sorry, I missed this here. Negative 3 times t is negative 3t, negative 3 times h is minus 3h, and I'm taking the brackets off here. So this will be minus 4t squared, and that'll be a plus 3t. And that plus 3t and that minus 3t will add to 0, so they're gone. So we expand the 4 in. So 4 times t squared will be t squared. 4 times the 2th is 8th, and 4 times h squared is 4h squared. Minus the 3h minus the 4t squared, and once again we get something to add to 0. That 4t squared and minus 4t squared is 0, so they're gone. So we just have these three terms, so that's what I wrote here. Didn't do any simplifying from here, just get rid of those. And then this h will divide into all three terms. So h goes into 8th, giving us an 8t. The h's divide out. H squared divided by h is just an h, so that becomes 4h, and negative 3h divided by h is negative 3. The t's divide out completely. And so we can now evaluate this limit as h approaches 0. See, I can't here yet until the h divides out, because if I put 0 in place of h here, this becomes 0 and this becomes 0, and I have one of those indeterminate forms, so I have to simplify that first. And so as h tends towards 0, this becomes insignificant, and we just have 8t minus 3. So that's the derivative of that function. Now we're asked to find the instantaneous rate of growth in the third year. So we take our derivative formula here and substitute 3 in place of time. So 8 times 3 minus 3, that's 24 minus 3, would be 21. And it's still a rate of change. Okay, same as the last question. So the rate is changing at a rate of 21 penguins per year. It's still growing. Question number 6. If you've downloaded the review, you'll find these two side by side. There's the B is over here. So, but I wanted to have enough room to show everything here. So I put this one here, and the B is on the next page. So in A here, we're asked to evaluate the limit of 9x squared minus 25 over 6x squared minus 7x minus 5 as x approaches 5/3. And this is actually one of those indeterminate forms, and maybe the simplest way is just to use the calculator so we don't get into all the fractions here. If I substitute 5/3 in place of x here, see my numerator works out to 0, and in the denominator 5/3, same idea, squared. Okay, so minus 7 times 5/3 minus 5. I get a 0 again. So we can't substitute 5/3 in place of x to evaluate, because we get that indeterminate form, 0 over 0. So that's why we have to simplify this. So we divide out a factor, the factor that's giving the 0 on top and bottom, so we can actually evaluate the limit, because it does exist. So we want to factor. So 9x squared minus 25 is a difference of two perfect squares. So we'll factor into 3x minus 5 and 3x plus 5. So that's how I factored the numerator. The denominator is just a normal trinomial we're going to factor, nothing really special about it, but it can factor. And so I'm going to factor it using decomposition. I want to find two numbers that add to negative 7 and multiply to negative 30. 6 times negative 5 is negative 30, and those numbers would be 3 and negative 10. And so I decompose the negative 7x into 3x minus 10x. And it doesn't matter, we already write them. If you want to write the negative 10x first and the 3x second, it doesn't matter. So my 6x goes first, and there's the 3x minus 10x, the minus 5 in the end. And so this is now factoring by grouping. The common factor here is a 3x. So if I factor a 3x out of 6x squared, I get 2x. And 3x factored out of 3x is a 1. There's a common error. A lot of people, when they see that, they think, oh, okay, it's gone, so there's just a 2x in here. But you're actually dividing each of these by 3x. 3x divided into that gives you 2x. 3x divided into this gives you a 1. And we can also factor out the last two terms at negative 5. So negative 5 factored out of negative 10x is 2x, and negative 5 out of negative 5 goes once. So remember, these have to be the same, otherwise you probably chose the wrong numbers here. So we factor a 2x out, and then the other factor is 3x minus 5. So that is how this denominator factors, 2x plus 1, 3x minus 5. And notice that those are that's what divides out. Those are the culprits that are giving the 0 over 0. Because if I take 3, I'm not going to, yeah. So if I evaluate, put 5/3 in place of x here, see, that's the part that's making the 0 on top and bottom up here. So once we divide those out, we get 3x plus 5 or 2x plus 1, and neither of these are 0, so we can now evaluate the limit. And so we put 5/3 in place of x here, 5/3 in place of x here. Those 3's divide out, so we just get 5 plus 5 in the numerator. In the denominator, it doesn't divide out, so remember that 2 is the same as 2 over 1. So 2 times 5 is 10 on top, 1 times 3 is 3. And I'm going to add that to the 1 here. So I'm going to change that 1. I'm going to multiply it top and bottom by 3/3, like that. So that's why my 1 became 3/3. So 5 plus 5 is 10. That's the 10 on top. And 10/3 and 3/3 add to 13/3. Now remember that 10 on top is being divided by this 13/3. So I'm going to take the 10 and multiply it by the reciprocal of 13/3, which is 3/13. And remember, there's really a 1 here. So 10 times 3 is 30, 1 times 13 is 13, so that's the limit. It's 30/13. So that's 6a. And here's the b in 6. Oh, I can get the whole thing on one screen here. So this is the limit, and again, if I substitute the 2, x is approaching 2 here, into the expressions, I can't do it right here. See, if I go and substitute that 2 in place of x, this is what happens. If I put 2 in here, so I get 2 minus the root of 4. The root of 4 is 2. So 2 minus 2 is 0. So we get a 0 on top. And if I put a 2 in here, 2 minus 2 is 0 on the bottom, I get, again, that indeterminate form, which is no good. So that's not what I want. I want to actually find the limit. So let's get rid of that, get rid of that. So the strategy here with the radical is to multiply top and bottom by the conjugate of that radical. So the conjugate of this would be 2 plus the root of 6 minus x. So that's why I'm multiplying by 2 plus the root of 6 minus x top and bottom. And in doing this, we're going to get, you see, this x minus 2 is the culprit that's giving us the 0. So I'm going to get that to divide out a little bit down the page here. So when we multiply these together, and if you're not used to multiplying these conjugates together, this 2 times this 2 is 4. Actually, I'll write this out over here. 4. So I've multiplied that. And then I'm going to multiply that 2. Whoops, here we go. That 2 by this. So yeah, that'll be plus 2 root 6 minus x. And then I'll multiply this by this, so that'll be a minus 2 root 6 minus x. And then this root by this root. Now notice it's the same root, except they are opposite in sign. So it'll be a minus. And when you multiply the same two roots together, you just get what's underneath the root. Just like root 5 times root 5 is 5, for example. Now, notice that these are opposites. So they add to 0. So that's why it's just 4 right here minus this, which is what I have on the end here. So that's how that all simplifies. And maybe we'll just erase this here. There we go. And in the denominator, I'm just going to leave as x minus 2 times this expression here. So when I take the brackets off here, 4 minus 6, and then this will change that into a plus x. And 4 minus 6 is negative 2, so this is really just x minus 2 in the numerator. And so that will divide out. See, that's what's giving me the 0 on top and bottom by put 2 in place of x. So they divide out. Now, x minus 2 goes into x minus 2 once, so there's still a 1 in the numerator. A common mistake here is to think that x divides out and we just get 2 plus the root of 6 minus x, and it's not in the denominator, is there's a 1 up here. So I can now evaluate this. If I put 2 in place of x, so there's my 2 right there. 6 minus 2 is 4. And so the root of 4 is 2. 2 plus 2 is 4, so the root is a quarter. And I'm going to graph this just to show that. So I've entered this original function in the calculator. It looks like this. And I'm going to use this window here. So this is what it looks like. Now, remember, x is approaching 2. So this is actually 2 right here. See the little break in the graph? So if we trace where x is 2, you can see that there's no y value because it's undefined. So if we actually go along here, so x is a little bit less than 2 here, 1.8, 1.9, is getting close to, see the limit's supposed to be a quarter, right? So see, you can see it's getting very close to a quarter. Quarter is 0.25. And if we go a little bit on the other side, and come down towards 2, at 2.1, it's 0.25, 158, etc. So you can see that it certainly does seem to be approaching a quarter. So that's what it looks like graphically. And on to the last question, number 7 here. In question number 7, we're given a couple functions and asked to find the derivative of each using the first principles definition. So I've got a polynomial one here and a rational one here. So the polynomial one first, the definition or first principles definition of the derivative is the limit as h tends towards 0 of f of x plus h minus f of x over h. And so to find f of x plus h, I put x plus h in place of x in my function. So that's -2 times the x plus h squared there. X plus h goes here, minus the 3, and then minus the f of x. So this, just to make this clearer, that is all of this. And the minus f of x is what's over here. And again, to find f of x is the original function. That's why that's exactly the same as what was in the brackets there. So let's get rid of my drawings there. So I'm going to square the x plus h. So similar to that shortcut I showed you a little bit ago, x squared is x squared. X times h doubled is 2xh, and h squared is the h squared here. Multiplying the 6 in here, 6 times x is 6x, 6 times h is 6h. My -3's disappeared because -3, and then this would be a +3. They add to 0, so they're gone. So taking the brackets off here, negative or minus -2x squared is plus 2x squared, and subtracting the 6x is minus 6x, and those will subtract to 0, so that's why I crossed those out too. So now expanding the -2 in here, they'll get -2x squared minus 4xh minus 2h squared. And again, that -2x squared and this 2x squared are opposites. They add to 0. So we just have these three terms over h. That's what's written here. Still can't evaluate the limit until I divide this h out, because if I put 0 in place of h, there's 0 on the bottom, and since these all have h's, that would be 0 on the top. It's indeterminate, so I can't evaluate the limit. So once this h divides out, -4xh divided by h is -4x. The h is divided out there. -2h squared divided by h is -2h, or minus 2h, and 6h divided by h is 6. And as h tends towards 0, that becomes insignificant, and so we just get -4x plus 6. So that is the derivative of this function. Question B, this rational one. So g of x is -5 over 3x. And so this is my first principles definition derivative. Because I called it g of x, so this would be g prime of x, and these are g of x's, not f of x's. So you should use the name of the function you're given. So g of x plus h, we put x plus h here. So it's -5 over 3, and then brackets x plus h. And g minus g of x is minus this, so minus the -5 over 3x. And I need to get a common denominator because these denominators aren't the same. The 3's are a common factor, that's okay, but this is an x, that is an x plus h. So I need to really multiply this one top and bottom by x, right here. And this one doesn't have the x plus h, so you need to multiply by x plus h top and bottom. They already have the 3's, so you don't need to multiply by 3 again, because they already have a common factor of 3 here. If you multiply by 3 here and 3 here in front of these, it would just make your factor larger, and you'd have to simplify it later. So it's not necessary to do that. So -5 times x is -5x. Positive 5 times x is positive 5x, and positive 5 times h is 5h. And those are opposites, so they add to 0. And this would be over 3x, x plus h, 3x, x plus h. And then over h. That h is that h right here. So I just simplified from this line to this line. They're gone. They add to 0. So it's 5h over 3x, x plus h over this h. And this guy on the bottom, that h is the same as h over 1. So I'm dividing rational expressions, so I take the top one, which is this one here, and I multiply it by the reciprocal of h over 1, which is 1 over h. And so those h's divide out. That's the culprit that's given me the 0 over 0 if I were to try to substitute 0 in place of h here. So they divide out. So I just have 5 times 1, which is 5 in the numerator, 3x, x plus h in the denominator. And so as h tends towards 0, this becomes insignificant, and we have 3x times x, which is 3x squared. So my derivative is just 5 over 3x squared. And that's the derivative of this g of x function up here. And that's the end of the review.